So our question for this week is, suppose we have a capacitor with a separation of 2 centimeters with a potential difference of 12 volts. We then slide a 1 centimeter thick beeswax, a chunk of beeswax with a dielectric constant of 2.7 between the plates. What is the change in the voltage? And does this increase or decrease the amount of energy stored in the system? Alright, so here's our initial setup and our initial values. Because we know that across these capacitors is 2 centimeters and the beeswax is 1 centimeter, we know that these chunks of air are each a half centimeter. What we're going to do is we're going to find the voltage across the beeswax, then the voltage across the air, and then add those together to find the new voltage, and then find the change from 12 volts. So here are our initial values. We have our initial separation is 2 centimeters, or 2 times 10 to the negative second meters. Our initial volts is 12. We're going to use this to find our applied E field later. The dielectric constant of beeswax is 2.7, and the separation of the beeswax, as we said before, is 1 times 10 to the negative second meters, or 1 centimeter, and the separation of air in total is 1 times 10 to the negative second meters as well. So here are our equations and some numbers. We'll get to that part later. So here we have the voltage across the air. The voltage across the air is going to equal this, which is our applied E field times the separation of the air. And here are our calculations for that, so that's going to equal 6 volts. The same way here with the wax, we use the applied E field, but then divide that by the dielectric constant. We also did that up here, but the dielectric constant of air equals 1, so it's not included. But the dielectric constant of the beeswax is 2.7, and then here's the E applied times the separation of the beeswax gets us 2.22 volts. So our final voltage, adding those together, is 8.22 volts. And if we find the change in voltage, we take the final minus the initial, which is 8.22 minus 12, which we get negative 3.78. So we can see that we decreased 3.78 volts. Now in terms of energy, we know that this is the equation for voltage. So we know that voltage is directly proportional to energy, or to the electric field, excuse me. And then we learned this equation in class. So we know that the potential energy is also directly proportional to the electric field squared. So we know that loosely voltage and energy are also directly related. So if the voltage increases, E field increases, or in this case, the voltage decreases, E field decreases. If the E field decreases, the energy will decrease. So the energy decreases along with the voltage.